Tape measures are used to measure large layouts. The steel tape is spring-loaded to retract into its carrying case when released. Most tapes have a lock built in to hold it in the extended position, but the return speed should be controlled. If it snaps back too fast, the hook could be damaged. Speaking of the hook, let's take a closer look. You can see that it's loose, slides in and out. This is so that you can take an accurate inside or outside dimension. As you can see, the amount of movement is equal to the thickness of the hook. You may have to take measurements in both metric or imperial units. The tape measure I have here is a dual scale tape measure, 5 meters and 16 feet. So it has both systems on it. The metric tape measure uses whole numbers, whereas the imperial scale uses fractions of an inch. So let's start with the metric scale. You can see this tape is divided into 5 equal portions called meters. Each meter section is further divided into 100 equal portions called centimeters. If we look at the beginning of the scale, we can see it goes up and stops at 10 and then starts over again with 1. This position right here would represent 11 centimeters, and so on up to 99 centimeters, 90, starting over to 9, representing 99 centimeters, and then our 1 meter location. Now let's look at the 1 centimeter portion between 99 centimeters and 1 meter. You can see it's further divided into 10 more equal portions. These are your millimeters. The 5 millimeter line is a little bit longer, making it easier for you to read. Now let's look at some examples. 91 centimeters is what this would be called. Now it could also be called 910 millimeters. Metric blueprints are always expressed in millimeters, no matter how long the measurement. This avoids confusion. Let's look at another example. What if we were right at this point right here? What do you think you would call that? Well, it could be 90.5 centimeters. Could also be expressed as 0.905 meters or 905 millimeters. I think you can see the potential for error here. A common mistake would be to call this point right here 95 centimeters, which of course would be incorrect. So it's safest to keep everything in whole numbers, which means converting to millimeters when you're working with metric tape measures. This is relatively easy because everything is in multiples of 10. Let's do one more example. What about this location right here? What would you call that? Well, that would be 1,010 millimeters. Let's have a look at our imperial scale now. Okay, this particular tape measure is divided into 16 equal 1-foot portions. Now each 1-foot section is further divided into 12 equal 1-inch sections, 12 inches making a foot. If we look closely at the portion between 12 inches and 13 inches, we can see that this 1-inch portion is further divided into 16 equal portions. These are called sixteenths. Now, if you notice that there's another number on this tape measure right here that says 1-1. That's adjacent to the number 13. 13 inches is also 1 foot, 1 inch. Now another thing I wanted to point out on this tape measure is the area between 11 inches and 12 inches. You can see it's divided again to even smaller increments, 32 portions, representing 30/2 of an inch for more accurate measuring. You will often see this on tape measures for the first 6 inches or 12 inches of the tape measure that will be broken into 30/2, and then after that broken into 16ths. A 30/2 is slightly smaller than a millimeter, whereas a 16th is slightly larger than a millimeter. The number I was pointing out earlier, 1 foot, 1 inch, adjacent to the 13, and you see again 1 foot, 2 inch, adjacent to 14 inches. Imperial blueprints are always expressed in feet and inches, whereas on the job site you could express it either way, feet and inches or straight inches. Personally, I prefer straight inches when I'm communicating with a colleague because there's less chance for misinterpretation. Now a couple of other marks that you see on a steel tape measure. Right here you notice that the 16-inch location has a arrow on it, and that repeats itself again when you get to 32 inches. It's identified. This is because 16 inches is the common spacing for framing of studs. Another mark you'll notice on the tape measure is this small diamond right here. It's located at exactly 19.2 inches, which is slightly more than 19 3/16. You can see it's slightly past the 3/16. That's difficult to see. It becomes a little bit more obvious when you look at the next one, which is at 38 and approximately 3/8. You can see it's past the 3/8 mark slightly. These particular marks are used to lay out engineered ceiling joists. So there we go. Remember, measure twice, cut once.